Well, apparently, my old video on 6.6 did not have volume, and so I have decided to go ahead and redo it and add some volume or add the ability for closed caption. Anyway, section 6.6, and this is a really important section as far as this chapter is concerned, because without knowing how to solve the problems in 6.6, 6.7 is going to be much more difficult. And what we're going to do is we're going to consider what we call rational equations, or solving equations with rational expressions. Now, I had trouble with this when I was a student because I never knew which steps to do. With rational expressions, we simplify by finding common denominators and then adding the numerators or subtracting the numerators and so on. But with rational equations, what we end up doing is we multiply by the least common denominator on both sides of the equation. So in the first part here, in example A, this is an expression. How do I know that it's an expression? There's no equal sign. And whereas in part B, there's an equal sign here. So what I'm going to do is I'm going to get a common denominator. Now, this is 3/2 t minus 5/7 t. Well, in this case, my least common denominator is the smallest number that 2 and 7 are both factors of, and that's 14. So I rewrite each one of these to have a denominator of 14, and I do that by, what do you multiply times the denominator here to get the common denominator? Well, that'd be a 7, so 7 times the top is 21. What times 7 gives me 14? Well, that'd be a 2, so 2 times the top, that would give me 10. And then I can subtract the numerators. In this case, it's subtraction, and keep it all over the common denominator. So I get 11, 21 minus 10 is 11/14, and then that's t because these are like terms. So I get the expression 11/14 t. Now, in the equation, what I'm going to do here, and notice here that my equation is such that it's 3/2 t minus 5/7 t. This is the same thing that I had just simplified by combining getting common denominators and combining the numerators. But in this case, we're going to avoid that. We're going to multiply through, and now notice here, it's got the equal sign, and it's equal to 11/7, so my common denominator is still 14. Common denominator is still 14, and what I'm going to do is I'm going to multiply both sides of the equation by 14. So 14, and then this is 3/2 t minus 5/7 t equals, and then 14 times the 11/7. So here I have to distribute, and let's see, 2 goes into 2 ones, 2 goes into 14 7 times, so this is 21t. That should sound familiar. Look right there, 21t. And then minus 14 times 5/7, 7 goes into that 1, 7 goes into that 2 times 5 is 10, so that's 10t. And then over here on the right side, 7 goes in that once, goes into that twice, and that's going to be 22. So now I have 21t minus 10t equals 22. I'm going to combine like terms. That's 11t equals 22. And then, of course, now what we're going to do is I'm going to raise this up just a little bit more here so you can see it. I'm going to divide both sides by 11, isolate the variable, and I get t is equal to 2. Now, most times when you're solving equations that have rational expressions, you have to check your answers. But since my denominators here were all numbers, the 2, the 7, and the 7, I don't have to do that. However, if the denominator has variables in it, and your LCD will have variables in it, and you multiply both sides of the equation by the LCD that has variables in it, you can pick up answers that would, for example, they would solve the transformed equation, but not the original equation. In this case, t equals 2 is a good answer. I can plug it back in to here, and I would get a true statement. Now, we're going to try some problems where the variable is in the denominator. Well, no, not right away we aren't. So when we are adding and subtracting rational expressions, keep the common denominator, the LCD, throughout the simplifying. Remember to do that. But when you're solving an equation, and that's what we're doing in this section, we're going to multiply each side by the LCD so that the denominators are eliminated. So we'll start again. We'll do something simple. Here I have x plus 5 over 5 minus x over 7 is equal to 3/7. My denominators are 5, 7, and 7. They're all prime numbers. So my LCD is the smallest number that 5, 7, and 7 both all divide into evenly, and that would be 35. So I'm going to multiply 35 times x plus 5 over 5. And I'm going to also multiply it times x over 7. Let's see if I can make that a little bit neater anyway. And also 35 times the right side, 3/7. 35 here, multiplied through. The 5 goes into 5 once, goes into 5 7 times. So that's 7 times the quantity x plus 5. Notice I put the parentheses around it, because if I don't, then I'm going to have just 7x plus 5, which is not the same thing. Minus, and then 7 goes in that 1, 7 goes in that 5 times. Now here I just have a monomial in the numerator, so 5 times x, that's just 5x. And then over here, 7 goes into 7 once, 7 goes into 35 5 times. 5 times 3 is 15. Now, I'm going to go ahead and finish this problem up. I'm going to have to distribute, because now I have a linear equation, just like we did back in chapter 2. 7x plus 35 minus 5x is equal to 15. Combine like terms, 2x plus 35 equals 15. Now my variable is being multiplied by 2, and there's a 35 that's being added to it. So I'm going to undo the addition subtraction step first. That's a plus sign there. It's by subtracting 35 from both sides. So 2x plus 35 minus 35 equals 15 minus 35. But remember, whatever you do to one side of the equation, you have to do to the other. And that gives me 2x, and 15 minus 35 is negative 20. Now I'm going to get rid of the 2 that's times the x by dividing by 2, both sides. And I get x is equal to negative 10. Now, it does say to check your answer, check the solution here. And so what that means is to check this, I'm going to substitute the negative 10 in for the variable here and here. Those are the only two spots that it's at. So I get negative 10 plus 5 all over 5 minus negative 10 over 7 equals 3/7. Well, I have to be really careful with these signs here. I'm subtracting a negative. That's the same as adding the opposite. But I'll go ahead and do this. This is negative 5 over 5 plus 10 over 5, or excuse me, 10 over 7 is equal to 3/7. Negative 5 over 5 is negative 1. Now, to add these, I have to have a common denominator, which would be 7. So I'm going to write this as negative 7 over 7. All right, so I'm going to add the numerators. Negative 7 plus 10 is positive 3. So I get 3/7 equals 3/7. Now, when you get the same number on both sides, that means it's a good solution, unless you've made 2 mistakes with your answer and your check. But that doesn't happen all that often. So just make sure you can always check your answers by substituting them in. Now we'll throw one in here with some variables. Okay, now the variables in the denominator are going to bring in the possibility of what we call extraneous solutions. Now in this case, the 4 is just an integer, it's a whole number. It's 4 over 1, if that helps. And so my denominators are 1, x minus 3, x minus 3. So my LCD would be x minus 3. So I'm going to multiply both sides by x minus 3. X minus 3 times the left side, that would be 4 plus 6 over x minus 3. And x minus 3 times the right side, which is 2x over x minus 3. Now here, nothing cancels, and I'm just going to multiply the x minus 3 times the 4. In fact, I'm going to write it as 4 times the quantity x minus 3. And then here, the x minus 3's will cancel out, and that just leaves a 6. On this side, the x minus 3's cancel out, and that just leaves a 2x. So now I have 4x minus 12 plus 6 equals 2x. I have 4x minus 6, combined like terms there, equals 2x. Now, normally I like a positive number in front of my variable, but in this case I'll save myself one step of work if I subtract 4x from both sides instead of subtracting 2x and then adding 6. So I get 4x minus 6 minus 4x equals 2x minus 4x. These cancel out. I get negative 6 is equal to, now 2x minus 4x, that's a negative 2x. Now I'm going to divide both sides by negative 2, and I like my variable on the left side of the equation, so I'm going to flip-flop the sides at the same time. I get negative 2x divided by negative 2 is equal to negative 6 divided by negative 2. I get x is equal to a positive 3. Now, that looks like a really good answer because it comes out to be a nice integer, but this is where we have to check our answers, because what happens when we check them is that when I substitute the 3 in for the variable, I get 4 plus 6 over 3 minus 3 equals 2 times 3 over 3 minus 3. I get 4 plus 6 over 0 equals 6 over 0. Well, you can't divide by 0. You can't have 0 in the denominator. So this is what we call an